What if I told you that the moon isn't there when you're not looking at it? Sounds completely insane, right? But that's exactly what one of the greatest physicists who ever lived suggested. Completely seriously, based on real laboratory experiments you can repeat today. 9 experiments to be exact. 9 results so strange, so quietly disturbing, that some of the smartest people on Earth now whisper a sentence they're not supposed to say out loud. Consciousness might be creating reality. Stick with me for the next 14 minutes, and I'll walk you through every single one of them, in order, building from the rock-solid mainstream stuff right through to the experiments physicists actively avoid mentioning in polite company. By the end, you won't be able to look at the world the same way again. G'day, you're watching Curious Physics AU. I'm not going to teach you anything today. I'm going to tell you a story. A story physicists have been trying to make sense of for nearly 100 years, and they still can't agree on what it actually means. Let's get into it. Number 1, the double-slit experiment. You've probably heard of this one, but stick with me, because the way it's usually told completely misses the punchline. Here's the setup. Fire electrons one at a time at a barrier with 2 narrow slits cut into it. Don't look at the slits, don't measure anything. The electrons behave like waves, leaving a beautiful interference pattern on the screen behind. Bands of bright and dark, exactly like ripples on a pond meeting each other. Now do it again. Exact same setup, exact same electrons. But this time, place a tiny detector at one of the slits. Just check which slit each electron went through. The interference pattern vanishes, just like that. The electrons start behaving like little particles, hitting the screen in 2 simple clumps. The only thing that changed in the entire experiment was that you looked. That's it. No physical interaction beyond what was already happening. Just the act of obtaining information seems to change what reality is doing. Physicists have been arguing about this since 1927, and nobody has a clean, agreed-upon answer. If you reckon that's just a quirky lab thing, hold that thought, because it gets a fair bit weirder from here. Number 2, the delayed choice quantum eraser. This one was dreamed up by physicist John Wheeler and actually carried out in laboratories in the early 2000s. Same general setup as the double slit, but here's the kicker. The decision about whether to look or not look is made after the photon has already hit the screen. Read that again. The choice happens after the event. And yet the result still depends on the choice. It's as if the particle goes back in time and decides what it was. Or, and this is the bit that genuinely does your head in, it never actually was anything in the first place until the observation happened. Cause and effect start to look optional. The arrow of time starts to look like a suggestion. If your brain's hurting right now, good. That means it's actually working. Number 3, Wigner's friend. This one started as a thought experiment by Eugene Wigner in 1961 and stayed pure theory for nearly 60 years. Imagine your mates locked in a sealed lab measuring a quantum particle. From their perspective, inside the lab, the particle has a definite outcome. Say, spin up. They wrote it down. It's in their notebook. But from your perspective, standing outside the lab, your mate and the particle are still in a quantum superposition until you open the door and check. Both versions are mathematically valid. Both are equally real according to the equations. So whose reality is the real one? In 2019, a team at Heriot-Watt University in Edinburgh actually tested a version of this experiment with photons. The result was as bad as you might fear. 2 observers can record genuinely different, equally valid, equally physical facts about the same single event. There's no agreed-upon reality sitting underneath. Just yours. And theirs. Yeah. That one keeps philosophers awake at night. And it should keep you awake too. Number 4, the quantum Zeno effect. Named after the ancient Greek paradox about an arrow that, in theory, never reaches its target because at every instant it's frozen in midair. Here's the modern version. A quantum system left alone will naturally evolve and change state. That's just normal physics. But if you measure it constantly, observation after observation after observation, it freezes. It literally cannot change. The watched pot doesn't boil. Confirmed in laboratories with trapped ions back in the 1990s and replicated dozens of times since, with everything from atoms to photons to entire molecules. Repeated observation paralyses the system. Look away, and it starts moving again. Imagine that for a second. Reality, on hold, because you wouldn't stop staring at it. The act of attention itself becomes a kind of physical force. Number 5, Bell's theorem and the entanglement experiments. In 1964, an Irish physicist named John Bell wrote down a deceptively simple mathematical inequality that was supposed to settle this whole mess once and for all. The logic was airtight. If reality is local, meaning particles have definite properties whether or not we measure them, then his inequality absolutely has to hold. Has to. No wriggle room. Spoiler, it doesn't hold. Experiment after experiment, starting with Alain Aspec's groundbreaking work in the 1980s, all the way through to the Nobel Prize-winning loophole-free tests in 2015, and the increasingly tight follow-up since, has shown Bell's inequality is violated. Every single time. What that result actually means is brutal. Either entangled particles communicate with each other faster than light, instantly, across any distance, or they don't have definite properties at all until they're measured. There is no third option that keeps everyday common sense intact. Now up to here, everything I've just described is completely mainstream physics. Boring textbook stuff if you're a quantum physicist. Year 12 HSC students working through Module 7 and VCE students grinding through Unit 4 will recognise some of this from their syllabus. But the next 4 experiments, they take this whole thing somewhere else entirely. Somewhere most physicists genuinely don't want to go on camera. So strap in. Number 6, the Princeton Engineering Anomalies Research Lab. PEAR for short. From 1979 right through to 2007, a group of researchers at one of the most prestigious universities on Earth ran experiments where ordinary people, just regular blokes and Sheilas pulled in off the street, were asked to mentally influence random number generators. Just sit there and try to nudge the numbers up or down with nothing but your thoughts. Sounds ridiculous, but across literally millions of trials, the results showed a tiny but statistically significant effect. The numbers leaned ever so slightly in the direction the participants intended. Critics tore the methodology apart. Defenders pointed at the staggering sample size and the consistency of the deviation. The lab eventually got shut down under quiet pressure. But the data is still sitting there, and nobody has properly explained it away. Number 7, the Global Consciousness Project. A direct spin-off of PEAR, random number generators scattered all around the world, dozens of them, running 24 hours a day, every day, since 1998. The hypothesis is wild. When something absolutely massive grips the human population at the same moment, Princess Diana's funeral, September 11, the 2004 Boxing Day tsunami, the New Year countdown, the generators should deviate from pure randomness in a measurable way. Over 20 years of continuous data, hundreds of recorded global events. The cumulative deviation from chance is, depending on who you ask, somewhere between mildly suggestive and statistically extraordinary. The odds against it being pure coincidence have been calculated as billions to 1 by the project's defenders. Critics say the analysis is post hoc and the events are cherry-picked. The data is open. You can download it yourself and have a look. I'll leave a link in the description. Number 8. Dean Radin's presentiment experiments. Hook a participant up to skin conductance sensors, the same kind used in lie detectors. Sit them in front of a screen, show them a random series of images, most of them boring, some of them emotionally jarring, like images of violence or distress. Measure their physiological response, the tiny changes in sweat and heart rate that happen when you see something shocking. Easy, standard psychology experiment. Now look at the data, very carefully, 3 to 5 seconds before each image is shown. Radin claims the body starts reacting to the upsetting images before they appear on the screen, before the computer's random number generator has even decided which image to display. Multiple replications across multiple labs, multiple stinging critiques. The debate is nowhere near settled. But if it's real, even slightly real, your nervous system is somehow running ahead of your conscious mind and ahead of the present moment itself. Number 9. Penrose and Hameroff's orchestrated objective reduction theory. So Roger Penrose, Nobel Prize-winning mathematician, working with anesthesiologist Stuart Hameroff, proposed back in the 1990s that consciousness itself arises from quantum events inside tiny tube-shaped structures in your neurons called microtubules. Wild idea, wildly ambitious. And for decades, it got dismissed almost reflexively. Quantum effects, everyone assumed, simply cannot survive in the warm, wet, noisy chemical environment of a living brain. The maths just doesn't work. Then, in 2022, a team based in Japan detected actual quantum vibrations inside microtubules, at body temperature, in conditions remarkably similar to those inside a living neuron. They didn't prove the theory. Penrose himself would be the first to say that. But they quietly removed the single biggest reason it was being laughed out of the room. And here's why that matters. If consciousness really is quantum at its base, then maybe it isn't a passive observer of reality at all. Maybe it's part of the same machinery that decides what's real in the first place. So now pull all 9 of those threads together in your head. The double slit, the delayed choice eraser, Wigner's friend, the Zeno effect, Bell's inequality and entanglement, PEAR, the Global Consciousness Project, presentiment, OR. Some of these are rock-solid, replicated mainstream physics. Some are deeply contested fringe science that proper journals barely touch. The honest scientific picture is messy. But the pattern those 9 experiments trace across the mainstream and the fringe alike keeps coming back to the same uncomfortable shape. Reality, at its deepest level, doesn't seem to be a finished thing sitting out there waiting for us to come along and discover it. It seems to be doing something with us, or through us, or because of us. Richard Feynman, the great physicist who inspired this channel, once said that nobody truly understands quantum mechanics. He was right. And the bit nobody talks about is that maybe the reason we don't understand it is that we are inside the experiment, not outside it. The observer and the observed might not be 2 different things at all. They might be the same thing, quietly looking at itself. The moon and the eyes that see it. I don't have a tidy answer for you, mate. Nobody does. And that, right there, is exactly what makes it the most interesting open question in all of physics. If this got your brain ticking, smash that subscribe button, because the next video on Curious Physics AU goes deep into the measurement problem itself, the actual unsolved core of all this, and what it might mean for free will. Drop a comment below telling me which of these 9 experiments genuinely messed with your head the most. Hit the like button if you made it this far. It really does help the channel. Cheers for watching. Stay curious.